All right, guys, continuing on with section 2 of chapter 1. This one's titled Order of Operations. So previously, we talked about how to express algebraic expressions verbally. And now we're going to evaluate numerical expressions by using the order of operations and evaluate algebraic expressions by using the order of operations. So some new vocabulary. We're going to talk about what it means to evaluate and what's called the order of operations. You're probably familiar with both of these, so this section will probably be somewhat of a review. So the admission prices for SeaWorld Adventure Park in Orlando, Florida are shown in the table. If 4 adults and 3 children go to the park, the expression below represents the cost of admission for the group. So an adult is $78.95, a child is $68.95, and this is the expression that represents the cost. So to find the cost of admission, the expression must be evaluated. To evaluate an expression means to find its value, and you can almost see the word value in the word evaluate there. Okay, so if we evaluate 3 to the 5th power, or just 3 to the 5th, what does that mean? Well, the base is 3, the exponent is 5, and remember the exponent tells you how many factors of the base to multiply together. So that's 3 times 3 times 3 times 3 times 3. So 5 factors of 3 multiplied together. If you bust out your handy dandy calculator, you get 243. Or you might know how to do that in your head. Either way is good. All right, so here's a couple for you to try. As always, go ahead and pause the video and hit play when you're ready. All right, we're back. So 2 to the 4th means 2 times 2 times 2 times 2. Which is 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 to the 5th means 4 times 4 times 4 times 4 times 4. And 4 to the 5th power is 1,024. 7 to the 3rd means 7 times 7 times 7, which is 343. All right, hopefully you got those right. And moving right along, the numerical expression that represents the cost of admission contains more than one operation. Remember, it had multiplication and addition. You had 4 times 78.95 plus 3 times 68.95. The rule that lets you know which operation to perform first is called the order of operations. So order of operation goes like this. First, you evaluate expressions inside the grouping symbols. We call those basically parentheses. But other grouping symbols are like fraction bars. They divide the problem into a numerator and denominator. The square root symbol can group whatever's inside the square root, the absolute value symbol. Sometimes they use brackets or braces instead of parentheses. Anything that groups an expression together is a grouping symbol. So you always do that part first. Then you evaluate all powers or the exponents. Then you multiply or divide left to right. And then you add or subtract from left to right. So an easy way to remember this is parentheses, exponents, multiplication, and division, and addition, and subtraction. So if you take the first letter, P-E-M-D-A-S, of each operation, it spells PEMDAS, or you might have heard, please excuse my dear Aunt Sally. That's a quick way to remember the order of operations. And you just have to remember that multiplication and division, it's like a tie. They both have the same power, so to speak. And addition and subtraction is also a tie. And the tiebreaker is whichever one comes first from left to right. All right? So if I want to evaluate 16 minus 8 divided by 2 squared plus 14, well, there's no grouping symbols. So the first thing I would do after that is exponents. So you would first apply the exponents. 2 squared is 4, so replace the 2 squared with a 4. Then you have subtraction, division, and addition. The next in the order of operations come division. So you would divide the 8 and the 4 and get 16 minus 2 plus 4. Now it's addition and subtraction, which remember it's a tie, and the tiebreaker is whichever one comes first. So a lot of times people want to do the 2 plus 14 and then they'll get 16 and say, okay, 16 minus 16 is 0. No, that's wrong. You have to do the subtraction first. So 16 minus 2 is 14, plus 14 gives you 28. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So the first one here, 3 plus 42 times 2 minus 5. You have to do the 42 times 2 first. So this becomes 3 plus 84 minus 5. And then the addition and subtraction. Addition would come first, so that'd be 87 minus 5, which is 82. Okay? And the second one here, you don't have any grouping symbols, but you do have an exponent. So this would be 20 minus 7 plus 8 squared is 64 minus 7 times 11. Now the multiplication would come next because that goes first before addition or subtraction. So you would have 20 minus 7 plus 64 minus 77. And then it's all addition and subtraction, so you just do that from left to right. 20 minus 7 is 13 plus 64 minus 77. 13 and 64 is 77 minus 77. And this one actually does come out to be 0. Pretty cool stuff, huh? All right. Now, when one or more grouping symbols are used, evaluate within the innermost grouping symbols first. And that kind of makes sense. Whenever you're doing order of operations, you do the grouping symbols first. Well, when you go inside the grouping symbols, if there's grouping symbols inside those, then you just start the order of operations over again and do them in there. So let's evaluate these ones. So 4 divided by 2 plus 5 times the quantity 10 minus 6. We have grouping symbols, so you do the 10 minus 6 first, which is 4. Then you have division, addition, and multiplication. So since you have multiplication and division, you do whichever one comes first. So 4 divided by 2 is 2. And then you have addition and multiplication. So multiplication comes first. 4 times 5, replace that with a 20. And then you get 22. Okay, how about this one? That looks like a big mess. Well, those are brackets. So you go inside the brackets, you have 32 minus the quantity 2 plus 3 squared. Well, inside the brackets, you have parentheses. So you have grouping symbols inside the grouping symbols, so just start in there. The 2 plus 3 you would have to do first, which is 5. So replace the 2 plus 3 with a 5. And then the squared is still on the parentheses, so you would have to do exponents before you did the subtraction. And now we're still inside the bigger grouping symbols of the brackets. So 5 squared is 25. Then now you just have subtraction. 32 minus 25 is 7. And 6 times 7 is 42. All right. Last one is an example. Now notice there's no parentheses, but remember, I said a fraction bar separates a problem into a numerator and denominator part. So you have to work those separately. I can't like divide the 5 and 9 or the 2 cubed and 15. Can't do that. You have to simplify the whole numerator and the whole denominator separately. So the 2 cubed comes first. That's 8. And then you have subtraction in the numerator and addition in the denominator. So we'll finish the numerator first. 8 minus 5 is 3. Then 15 plus 9 is 24. And then 3 over 24. Don't write it as a decimal unless they tell you to, but you do want to reduce the fraction. So the 24 and the 3, you can reduce both of those by a factor of 3. So it comes out to 1/8. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, the first one, we got to go inside the grouping symbols. So that'd be 5 times 4 parentheses times 2 plus 20. Now all that's left is multiplication. So you do 5 times 4 is 20 times 2 plus 20. And then that would be 40 plus 20, which gives us 60. Okay? 60 is the answer for that one. All right, next one, you got to go inmost parentheses first. So it'd be 15 minus bracket 10 plus 1 squared bracket plus 6. Still inside the brackets, you got the 1 squared. Now it's not 2. Be careful. A lot of people will write 2, but remember, this 2 means multiply 2 factors of the base or 2 factors of 1 together. What's 1 times 1? Right, it's just 1. So 15 minus 10 plus 1 plus 6. So 15 minus, and the 10 plus 1 is 11. Now, once you do everything inside the grouping symbols, you can get rid of it if it's not multiplication. So the 10 plus 1 is 11, and then that just becomes 15 minus 11 plus 6. And again, when you have addition and subtraction, you do whichever comes first, left to right. So 15 minus 11 is 4 plus 6 gives us 10. Okay? That's the answer to that one. Last one. You have a fraction bar with grouping symbols. So you just treat it as two separate problems, a numerator problem and a denominator problem. The numerator becomes 4 plus 5 is 9 squared over 3 times 7 minus 4. And then 9 squared is 81 over 3 times 7 minus 4. And then 7 minus 4 is 3. And then that becomes 81 over 9, which 81 over 9 becomes 9 over 1, or just plain old 9. Now, if it doesn't reduce completely, just leave it as a fraction in lowest terms. Okay? All right. Well, that's it for this part of the section. In the next video, we're going to talk about how to evaluate algebraic expressions. We'll see you there.